All right, so we've been talking about linear equations and we're in section 4 or 5, and this is the part 2 video. Here we are with example 3. So we're going to use the graph of a linear equation in this particular example to help us solve a problem. So here we go. Carlos swims every day. He burns about 10.6 calories per minute when swimming laps. So the first thing we're asked to do is to graph the equation C is equal to 10.6 times T, where C represents the number of calories burned and T represents the time in minutes spent swimming. And if I haven't said this to you before, I want you to hear me now. Generally, when we're talking about time is usually going to be in the horizontal, on the horizontal axis. Time is usually the independent variable, and we will refer to it oftentimes in algebra when we're dealing with any concept, like any type of problem. So I want you to keep that in mind. So we're going to have our time across the bottom and we'll have our calories burned along the side. So I've taken the opportunity to kind of, I'm going to zoom in here to make a table. And the table that I made, not a table, sorry, to make a an XY axis to graph. And the graph that I made, notice that I numbered by fives here and I numbered by hundreds, well, 50s if you count every line over here. And there was a decision to do that based on the information given and also based on glancing at the next part of this problem. They asked about 350 calories, when would that happen? So I knew that if I was going to be able to make a graph that was going to help me answer this, I need to make sure I go up high enough. And I knew that my values here had to go out far enough. And we'll talk a little bit about that. Please ask me about that. How to number your graph, how does it make sense, because there's a little nuance, you got to think about it. All right, and so to graph this, basically we're going to think about doing a table. So the calories would be equal to 10.6 times T. It's a linear equation, so I can plot a few points and then draw a line. I'll put my T value here and my C value here, and I'll choose some values for T. Let's say 5, 20, and 40, and I'm just going to multiply these values with 10.6, right? Because T times 10.6 is going to give me the T value, correct? All right, so when I multiply over here, I end up with 53. 10.6 times 5 gives me 53. When I multiply here, I end up getting 100, 200, 6. I get 200. Oh, my bad, I got 212. My brain wasn't working there. And then when I multiply 40 times that, I'm going to get 424, I believe. And if my numbers are wrong, you guys will tell me, I'm sure. And so what I'm going to do is now plot these points. So at 5, I have 53. So that's about at 50, but a little bit more. And you'll see the guesswork that you have to do with these graphs. They're not perfect or precise. At 20, I'm over here. I'm going to go up to 212. So that's 200. 212 has to be slightly a little bit more, just about there. And then at 40, I'm all the way up at 424, which is off the chart basically. So I've got something that does this. You can see the inexactness of what I'm doing. And then I'm just going to draw a line. At 0, I should be at 0, which makes sense, right? If he doesn't do any swimming, he doesn't lose any calories, at least not that way. And so my graph looks something like this. Then it asks me, suppose that Carlos wants to burn 350 calories. I go to my calorie section and I identify where 350 is, and 350 is about here. Let me make this a little bit smaller. So 350 is around here. And so I'm thinking about taking this line across to see, here I'm using my graph, take this line across and see where it kind of meets the graph to see what the amount would be, how many minutes of swimming would I need to do. And I'm coming down just before 35 minutes. So it looks like approximately how long, maybe it looks like 33 or 34 minutes would be needed in order to swim, or in order to lose 350 calories. So the time would be what did we say, 33, maybe 33 minutes. And that kind of makes sense if you think about, because it's not like you're not multiplying by 10, you're multiplying by 10 point something. So it wouldn't be 35, it would be a little bit less than 35 because there's the little 0.6 when you multiply. Should be around 350 calories. You guys will check it for me. You'll let me know. But that's how you can use your graph in order to answer some questions. So this last example is really, it's important, but it's also really helpful. And so you remember we talked about x-intercepts and y-intercepts, and we said that x-intercept is a point such that the point is going to be x comma 0, and that point is going to refer to the place where the graph crosses the x-axis. Right? And on the x-axis, all the points are going to be some x value with a y value of 0. And then the y-intercept is going to be 0, comma, some y value. And so that's what we're looking for when we're talking about the x-intercept and the y-intercept. And if you've noticed, really to graph a line, all you need is 2 points. So if you can find the intercepts, if you've got two different intercepts for your line, you can graph that line. So let's see how we'll do that. So I've started off by creating my x and y axis, and the next thing I'm going to do is I'm going to act like I'm going to make a table. And I am going to make a table, but it's going to be a super small table, such that one point that I'm concerned about is what happens when y is equal to 0. The x value is what I'm concerned about. When I do this, I'm going to get the x-intercept. The next point I'm concerned about, the next point, is going to have what happens when x is equal to 0. Whatever y value I get here will give me my y-intercept. That's going to be 2 points, and the only 2 points I need in order to graph this equation. So I take the equation, which we know to be 3x plus 2y equals 9, and I'm going to replace, to figure out what the x-intercept is, I'm going to replace the y value with 0. So I get 3x plus 2 times 0 is equal to 9. When I solve this, I get that 3x equals 9, which tells me that x is equal to 3. So x equals 3 tells me that 3 is the x-intercept. So when y is equal to 0, x is equal to 3. Here's 1 point on the line. The next point I'm going to figure out is the y-intercept, and as I said before, I'm going to just put 0 in for x and solve for y. So when I put 0 in for x, 3 times 0 plus 2y is equal to 9. This thing goes away because 3 times 0 is just 0. 2y is equal to 9. Divide both sides by 2, I get that y is equal to 4.5. So when y is equal to 4.5 on the y-axis, right, that's our y-intercept. And so I go to 4.5, 1, 2, 3, 4 and a half right here, and basically I have my line graphed already because all I need is 2 points to determine my line, and I've got the 2 points that I need. And so this line that I've created here is the linear equation, is the representation of this linear equation. All right? I hope that made sense to you. Please let me know if there's any questions that I can answer. I happily will do so, and I look forward to seeing you soon. Take care.